If some of you have a better alternate things, you can tell me. Once again, coming back to like yesterday, I think you should familiarize yourself first with all the dimensions that are possible. A and B in this case refer to the mounting dimensions, so that in case you want to make your own hardware associated with it, you can use it. You see here, C talks about the clear length of the width of the, I am sorry, in this case let me call it You have seen this? Very, well, I won't call it clever this thing. It is not a new model, improved shampoo, which will make sure your hair will grow as you want and turn and so on and all that, but heat source is applied on the opposite side of the fins. But that is not the condition which was shown. You have seen that, no? This is a condition in which the thermal resistance is included. Let me get back and see. Depending on the length, as the length and width and all increases, they have given a beautiful thermal resistance rate of degrees centigrade per watt. This is the thing which I was pointing out in the initial stage. If you see that nice beautiful star, thermal resistance test conditions in which they have done this. So, if there is a way of you are transferring all this and keeping it, I am sorry, transferring all the heat to one of the reference surfaces and keeping it at that necessary various temperatures, ambient air cooling, heat sinks are set perpendicular to the ground and temperature of 60 degrees centigrade, meaning that whole surface is about 60 and ambient in this case he has not specified, generally they take around 25 degrees. So, with this, in these conditions thermal resistance is degrees centigrade per watt. So, if you are to have let us say an amplifier which is giving 100 watts, that to multiply it by 100, end up with 700 degrees. Not necessary, I am sure you think that you do not know that. I know very well you know that, only the thing is generally the efficiency of the circuit and all that, it comes into picture. So, typically if you take the worst condition, maybe around loss of 10% may be there. All the power input and into the power output minus the difference is the total power dissipated in somewhere or the other. So, multiplying by 10 you may get about a 70 degree rise across the temperature difference and so on. Based on this, now you need to work it out. Then as becomes bigger, it becomes smaller and smaller. So, I will take you in fully all the way in, and then you see here we have different colors and then there is dimensions. At the bottom of it, this is the heat sink conditions and all they have put here. Cross section view is given quite a bit in detail at this point. I will try to get a little closer and show you what are all the details. Yeah, I think this may be a better choice. you see something. So, we have a lot of details about how to assemble that nut, and at the bottom issues about the grooves and where the several other things can sit here. One of them is the printed circuit boards can sit here, or you can have a chassis plate like thing which can sit here. So, lot of details about the grooves and all, and then yesterday if you remember I spoke to you why the grooves are typically around at 1.7 to 1.8 mm. They are all related to the average that printed circuit board, which is after applying I think it's called some 1 ounce copper, that if around 35 microns or I think 0.3, I am sorry, I am not very clear about it with this thing. Overall it comes a little around 1.6 mm, depending on the length of contact and how well we can assemble it, groove width may be a little more or less, and then they have given a small taper also. While the dimensions are not fully specified here, if you take one piece and measure it based on the tolerances, chances are you will never go wrong. Tolerances are extremely close for this 6063 extrusion. So, these are all a matter of detail about how it goes little deeper and so on and so on. So, I will try to go down inside a little to see can find more appropriate things as we go down. See here many more things are here. You see here one small very interesting and characteristic thing is the bottom of this panel fully covers the extrusion there, and then top this panel there is a small groove here which clears this top surface. And why these distances and all are all given very clearly is that when you assemble these big screws and all that, all the detail has been very carefully worked out. You have seen that here. You see this 4 into M3. It probably comes pre-tapped. So, you have an advantage here. It in no way interferes with this, the M3 nut groove where the nut goes inside, and depending on the manufacturing process I told you yesterday, sometimes the nut is kept there, sometimes they use a fixture to align the nut up front. So, you align all the 4 nuts and then after that you peacefully can assemble the PCB. You see here this is very critical. This is where now I said professional engineering helps in making sliding nut, saying as a built-in groove, these are all the standard accessories, and then this, as you said, this just shows their capability, but it is a little like the drawing which you have seen earlier, except that here it uses heat sinks on the sides. Okay, I will go down further. This is very similar to the one that you have seen. Most likely it is the same thing that has been there. So, at this point I will leave you back to where we have started, because it will be unnecessarily repeating what I have done. Everything else is about the same, except that the front panel has a clearance here and you have all the professional things. So, if I can have the camera, sir. This is something which we have attempted using extrusions which are used for our construction. Not the best, I fully agree. It's in fact it's not at all good. This is not the way to do it, but I am very happy that I attempted it. We have taken one of these extrusions here, normal extrusions, added 2 end plates and made a small provision here to assemble the screws, that is a small what you call aluminum spacer of the full length has been carefully slit, pushed inside, and that spacer also has provision for us to mount printed circuit boards and all. So, smoothly we push it from one side, then afterwards including the printed circuit board, and then you assemble it, it is held tight. And on the other side we have these other openings. We have made provision here in the case we want, we can always have any of the heat dissipating components and all have a heat bridge like thing which is tapped inside. So, after pushing it in with a little gap, maybe around 0.5 mm sliding, we have a special fastener which goes inside with a small taper, and as we tighten it, it pulls the heat bridge and makes it sit flush across. So, we have a heat bridge which now transfers all the heat to the box, and then this box being continuous, we have found out that it is quite effective. We have managed to dissipate around 10 or 15 watts with our ambient here in Bangalore being around 30 degrees. And we have noticed by using a small thermistor mounted inside that the temperature of the heat bridge has not exceeded around 90 degrees, which I feel is a very good this thing. I just wanted to show you that you can probably do this in case you are curious and you enjoy a little bit of this tinkering. Take standard aluminum extrusions which can be heat sinks, heat sink 1, heat sink 2, and then somehow join together, make a box like thing, make end plates, and directly you are in this thing. But then as I said, it will still be, in spite of the best analysis, it may still be a borderline how do I say, trial and error, hit and miss approach, because specific conditions about the heat transfer coefficient across this is not known very well. At least there you have a guiding figure. So, this is one of the things, I will see whether I have more pictures which I wanted to show. Sorry. Somebody is watching. Yes, I think finally I could locate it. Now, if you see a little carefully, the fact that there are a few fasteners here and something here, the whole thing may be a special heat sink that has been made specially for them. Alternatively, it is very much possible for you, if you can get a long heat sink like this, cut it somewhere and make one of these ends like this into a surface on which you can mount all your beautiful things here. I do not know, I am not able to check from here whether I am able to get a heat sink or not. This is the one which I wanted to tell you. You see here, the reality of any of these devices is heat loss, and the only way of, at least in our case of our this making any of these enclosures and all that, is somehow you have to deal with two things. One is how to transfer heat across, another is how to keep them sealed. So, imagine a condition where somehow sealing is critical. So, very best way is, if you can I can get back to my thing, very best way is try to somehow make them touch the surface from inside. In my case, I told you how to do it. Alternatively, if you have certain grooves and extrusions and all inside, you can try to mount all your heat dissipating things inside. Alternatively, you can have a heat sink like, rather heat extrusion which has grooves on both directions. You understood? Inside there are grooves like this, outside there are grooves like this across. I am not able to do this, I expect it is there. You understood? Imagine a plate with grooves on both the sides, and now use that as one of these faces. Now inside, if you just recirculate the air properly, that is enough for you to have convective heat transfer inside to the surface and from there to the ambient. Some of these manufacturers also give this. In the case that you do not have access to that, you can always make your own reasonable sorry, I mean it crashed a little while back. I will see if it loads. So, if you go and have a look at this catalog, one of the thing you will notice is there are so many of these which are available. Heat sink enclosures, like and then the most critical thing about it is, in case you have a full drawings are available. At this point, I hope it is downloading. Yes, something has downloaded. I would like to point out something I am sure you will coming back again to these drawings which are available. Good, we are lucky. You have seen here, this is what I was trying to tell you. There are, you probably need a little bit of, well, I won't call it a full engineering skill. I am sure all of you would have acquired it in the normal course. What I wanted to point out, that you have a, you have seen this top and bottom covers are there. Notice something very interesting about it. There are openings on the top cover which correspond to heat sinks here. Seen this? Further, if you go down, this may be little more self-explanatory. So, we have the heat spreader here, then there is a top and bottom cover, therefore, what do you call, pillars. I am not saying you copy this design, but because I am 100% sure that numbers what they have given is extensively because of the quality of the material. So, copying these dimensions will not take you anywhere. One thing it will guarantee is that your equipment will fail, and while IP is another issue, chances of failure are very high. So, for the first 2 or 3 units which you would like to have, which this thing is the first whatever breadboard, which I will still call it not a full fledged prototype, a technology proving thing, you should start with these enclosures. So, once it is proven and you are sure, then negotiate and get more of them. Do not try to make it on yourself. That will be a real problem. Okay. I will just close it at this point. Same time you will notice that two more things have been given here. Okay. This I thought if I get a practical chance, I have asked one of my colleagues who works on EDA tools. These dimensions that is given here, if you work with a package which can understand original Autodesk's DWG format, it is good 100%. Release is a little issue, but all of them right from I think R12 to whatever current issue, these things open, and most EDA packages allow import of outlines from here. If that is not allowed, you still have DXF. I will try DWG because I expect that it works without much problem. I hope it is opening. Oh, what happened to my there. Wait sir, do not show, let it come. After it loads, come, because it takes a little time to load. So, you see here that same drawing which you have, which was in the PDF format, is now available for us to open with any of the readers. So, you have to be little careful, but you have seen this, even these cross sections and all now. They have given a beautiful thing saying 1:4. You have to be little careful about this thing, but the important thing is you can directly pick outlines, dimensions, everything from the drawings that are supplied in the catalogs. So, instead of trying to start with an EDA automation, you start with a screen and then pick corner here, corner here, corner here, and then have a schematic capture, and then after that slide to place components and make a rat's nest. It will be too late. You can't do much with it. Instead, you can go back to this DWG or one more DXF is there, that is drawing interchange format. So, this format things, if you pick directly from there and make a provisional layout of your equipment, especially where heat dissipating components can sit, where heavy components need to be placed, and most important, the very ubiquitous and the most unreliable connectors. I am not saying these connectors are unreliable. By misuse, you see here, this is a beauty, absolutely. Not misuse, I am sorry for the English wrong this thing. This is the beauty of this thing, but at best it follows only the layout that is practically possible inside. So, eventually when I assemble it, I can take my mobile and then try to charge it. So, criticality of using any of these extrusions is you need to be prepared with the details of the extrusion, including how much of space is there, where all we are likely to have our thing. But in the case of these what you call construction hardware, generally they guarantee that this is 30 mm, this looks like 60 mm. So, I have a 60 mm by 30 mm extrusion, but of course here they use inches, most likely it is 1.5 inch or yeah, 1 1/4 inch versus 3 inches extrusion, little, yeah, little less than 3, 2.5. External sizes are compatible and it goes and sits against a door opening or a door jamb, but inside details come with that small star. Terms and conditions apply, they may change any time. It is not to fool us, or it not us to buy a improved what you call shampoo. It is only to make sure to optimize the manufacturing and the use already like that. Often this hardware, the corner brackets, hinges and various other mounting hardware keeps changing. So, something which is 10 years old or in our case maybe 30 or 40 years old is not automatically applicable. So, however, if you contract with the supplier, most of these extrusions you can use them directly. They are not optimum, still available, but I still prefer you go to a professional supplier, okay, and then try to deal directly with this. So, at this point I would like to say thank you for your patience. Please look up the internet, and secondly, go to a fabricator, locate some people and they have to work parallelly with you. That old so called over the wall works in most conditions, but if you are an innovative designer and you would like to start fresh, does not work. I just wanted to show you, this is not a very old concept or anything. You see a watch here. For a long time all these watch cases were extrusions, okay, and some of them are even stainless steel extrusions. Stainless steel extrusion, shocked, yes. At least aluminum is standard like that, but after this other what you call acetal copolymers and so many other things, no, I think it is called some rhinite and so many other things have come. This copolymer cases are equally good, except that impact resistance is probably not as good as a this thing, and then a lot of times we do not select things only for the functionality. There is also the little cues you want, visual cues. So, if I show you this item, this whole thing can be made probably out of cheapest possible styrene, which happens with several of your bottle caps and all that, and coated with copper and nickel. But this particular one is a zinc die casting. So, if I strike it, you can probably hear the sound. I will see. I am not able to hold it correctly. This is a zinc die casting. Why they have used zinc die casting is, this is probably taken from an earlier design, saying the unlikely case it drops, it is quite heavy, 4 into the cells, I do not know, the whole thing may be weighing around 300, 400 grams. Nobody will take too much about this if it breaks, but if it I mean if it injures something and there is a problem. So, they try to make this nice rounded corners and all. Simple, easier to weigh is make a enclosure like this, and probably the whole thing is also made with necessary inserts. Probably the back end, the rear and the front portions are all made with the same thing. Either this has been subsequently milled, nobody will do that, or it is made with some inserts, which making, say after making 100,000 pieces of this, you can make 100,000 pieces of this, and extrusion comes continuously, it cuts, and then the corner they have used normal self tapping screws. These are equivalent to M2 self tapping screws, very routine thing. So, I managed to get it for about how would I say $10, $10 or $15. It costed me a little more, $20. It costed me around 1000 rupees, maybe around $15. For $15 for me to buy, obviously there are markups at every stage. The same thing would have been about 1/4 of the size. And I am proud to show you a sample, very routine normal thing also is expected to have impact resistance. You remember last digit in the IP class, there is one more last digit, IK class. There, depending on how much it can injure you and how much things it can take, we have a beautiful sample of a thing here. So, I will take a break at this point. Let us meet again with little more details on if at that time I can get the samples about the interconnection devices. So far I have covered the enclosures part, a little about the heat and all that. So, two things and then a little about the fabrication and details about it. Two things which are still related to this is non-electronic or non-electrical hardware, which are the borderline, what you call a million shades of grey, it is not just 50, are the connectors, especially they have a fantastic function, how to give a loose contact. So, added to that we have a problem of if you have to take any of these hybrid on the go drives and all that, we carry them everywhere we want. So, they are still prone to various types of exposure, not necessarily indoors, and body fluids like sweat and in my case of a hearing aid, all the earwax and even saliva and all that is not good. It corrupts absolutely. So, the moment any of this go into that connector area, it leads to a lot of problems. So, I am sure when something is sold at low price, we call it cheap, which is the best way of describing cheap products. First thing cheap products fail is probably at the connection. Second thing they fail is inside, which is again all the manufacturing technology. And we guys, the box fellows, otherwise enclosure designers tend to get blamed because the functionally the electronics has worked on the bench and even it has passed a few tests, but in due course enclosure may fail. So, to prevent it, all the action can be done, and then in this case we try to improve on it further. You have seen these two grooves here. We have thought of saying why can't we have a lip here, you understood, means all around a cup like thing is there and part of it goes into the groove to the extent of about 6 or 8 millimeters. Once we push it inside and then try to make this tight, we do not need, there is no necessity of these screws at all, understand. No, we try to fix that directly with a what is called a riveted clinch nut inside. So, you do not have this ugly face, and then this can be used as a nice front panel. So, thank you. I will stop here. Thank you.